Right, hello and welcome to lesson 2 on identity specifically. In this lesson we'll be finding products and we'll be using difference of squares. Right, so I hope you follow. I'm Mr. Simons. Start to the problems, only problems and answers. Right, so problem number 1, why we can say difference of squares. Should see in that first bracket I have cos A plus sin A. Second bracket I have cos A minus sin A. I have the same terms in each bracket, but one is positive and negative, so therefore that means difference of squares. I'm only going to multiply first term by first term and last term by last term. Multiply out, I need to work till I get the answer on the right hand side. So my left hand side, it's given there, cos A times cos A would become cos squared A. Positive times negative would become negative. Sin A times sin A becomes sin squared A. Alright, I have cos squared minus sin squared A, which in theory I can write as cos 2A and then just expand. But just to show you, sin squared A according to the squared identity is 1 minus cos squared A. No? So there, negative times 1 gives me negative 1. Negative times negative become positive. Cos squared A plus cos squared A then gives me 2 cos squared A. So this equal my right hand side, so my left hand side, my apologies I didn't type that in, but I've made this now look like my right hand side. So I've proved the identity. Look at the second problem. Now I have cos to the power 4 theta minus sine to the power 4 theta equal cos 2 theta. So there, perfect square separated by minus sign, so I have difference of 2 squares. Right, so if I factorize, right, that would become cos squared theta times cos squared theta. Remember, when I multiply and the base is the same, I add exponents, so 2 plus 2 must give me 4. Same thing applies to sine, that would be sine squared theta times sine squared theta. One bracket must be negative, other one positive, because only negative times positive will give me a negative. Right, now according to the square identity that you've learned in grade 11, cos squared theta plus sine squared theta equal 1. So there in place of that bracket I place 1. Cos squared theta minus sine squared theta then equals, if I reduce it, cos 2 theta, which equal my right hand side. Right, it's part of the double angle. If there's anything you forgot, like your square identities and so on, just log on to Simon's Math 11. You can go re-practice your grade 11 trigonometry. All the lessons are there for you. Right now, you have tan squared b minus sine squared b in problem number 3. You must get it to be tan squared b times sine squared b. So again, perfect square, tan squared, sine squared, but they have a minus, so I have difference of 2 squares. So tan squared b is simply tan b times tan b. Sine squared b is simply sine b times sine b. Right? To solve, I'm going to change tan b to sine b over cos b. You see there tan b is sine b over cos b. To add it to that, my denominators must be the same. So you see for sine b, I simply multiply it by cos b over cos b. That side as well, for sine b, I just multiply it by cos b over cos b. Because I have plus and minus, the only way to add fractions is if the denominators are the same. Right, so on top, I can write now sine b for my numerators, sine b minus sine b cos b over cos b, and there's sine b plus sine b cos b over cos b. Right? There in blue you should see between the minus sign, separating terms, there's a common factor sine b. This side as well, on either side of the plus sign, there's a common factor sine b. So I take sine b out, sine b divided by itself gives me 1. Sine b divided by sine b is 1, but 1 times cos b simply stays cos b. Negative stays negative. This side, if I take out sine b, I have sine b. Sine b divided by itself gives me 1. Sine b divided by sine b, 1. Right, and I'm left with cos b. All over cos b. Right? Now you see this sin b over cos b and that sin b over cos b, I can change to tan b. So they have tan b times 1 minus cos b, and they have tan b 1 plus cos b. Tan b times tan b would give me tan squared b, and then I'm left with 1 minus cos b times 1 plus cos b. Again, same terms in the bracket, but one is positive and the other one is negative. So difference of 2 squares. 1 times 1, 1. Negative times positive, negative. Cos b times cos b, cos squared b. But according to the square identity, 1 minus cos squared b can be written as sin squared b. So therefore that becomes sin squared b, and I have my right hand side. So I hope you follow. I try to go through it as slow as possible. Pause, rewrite to follow. Right, different learners have the different ways. Make a note where you make an error, etc. Right, but continue practicing. If you enjoy my explanation, you want to stay up to date with all the videos coming through, please subscribe. If you like it, like and share. Thank you.